To give you an idea of where it is and how you get there, I flew from Italy to New Zealand, and then from New Zealand on a military plane, the C-130, to the coast of Antarctica, to the base called Mariuzakeli, and then took a smaller plane, this Basler, to Concordia, which is in the middle of the eastern Antarctic plateau. But why this particular location for a base? I mean, it's far from the coast. There are no studies that you can do on the ocean. There are no animals. There is nothing. But it is very important for the natural sciences. First of all, it's situated on an ice plateau of 3,300 meters. So it's very interesting, and I'll go into this in a bit more detail, to study paleoclimatology. It has very good atmospheric conditions for astronomy. It's a good location to study the hole in the ozone layer. It's a long way from the ocean, and it's a long way from other Antarctic bases. So it's a great place to study geophysics as well, because there aren't any perturbations around there. And also, interestingly, it's for the people that live there, they're particularly isolated conditions. It's a very hostile climate, so it's an interesting place to study human behavior in such conditions, which are very similar to what you would have in a space mission. It all started with this project called EPICA, European Project for Ice Coring in Antarctica. Back in 2004, they managed to drill an ice core of 3,200 meters. And they cut up this ice core into small pieces, and inside there were air bubbles that they could use to study what gases were there. And correlating the gases, correlating the depth with the year, they were able to measure the gases that were in the atmosphere going back about 800,000 years. So these are the graphs that they got. They got basically the methane and carbon dioxide cycles over many, many years. And indeed, they found that recently there has been a huge increase, as we all know, in the concentration of carbon dioxide and methane in the atmosphere. So this was a very important study, and they decided that because of this breakthrough study, they would build a base on that location. And this was the very first camp that there was at Dome C. There was no base, but they basically lived in tents, and they did this ice core drilling. But eventually, they had an agreement between France and Italy to build a research station there, and it's actually the only international research station in Antarctica. So it's the only combined state station. It was completed in 2005 and opened for its first winter. But as you can see, it started with the frame, and it took them a number of years to actually build the base, because they could only do it in the summertime when the conditions were made it possible. They were working out there in these warm suits, and then finally they managed to build the base. But how did they get there, given that it's right in the middle of the Antarctic plateau? Well, they arrived with what's called the raid or the traverse, and this is a series of tractors that come going at about 10 kilometers per hour, so very, very slowly. They take anywhere between 11 and 16 days to arrive from the coast, bringing in materials overland. This still happens 3 times per year, only in the summer period. And when I say summer period, that means from December to February. And they bring in supplies like food and fuel and so on, and they take away any waste products. And now we have this wonderful base, and these are the studies that take place there: astronomy, astrophysics, atmospheric sciences, earth sciences, glaciology, human biology, and remote sensing. Obviously, you can't just go there without any preparation. So my preparation was with PNRA, the Italian Polar Sciences Institute, because it was for all the members of the expedition. We had to also learn what to do in the sea, so we had to learn how to drive boats and fall out of them wearing a dry suit. A very important thing to learn was firefighting, because the air at Concordia is particularly dry, and So anything can cause a fire. So we did a lot of firefighting training. We also spent some time in cold conditions on the glacier of Mont Blanc. And this down on the right-hand side here is my team. So for the winter over period, there were only 13 of us. And so we had a week together beforehand, just getting to know each other and doing team building. To get there, as I said before, I went via New Zealand. You have to wear your Antarctic gear before you get on the plane, even in summer of New Zealand, because if something happens to the plane and you have to touch down in the middle of nowhere, then you have to be prepared. This is just as you're coming into Antarctica, you can start to see the sea ice. Then finally, I arrived at Mariuzukeli Station on the coast. You can see there those mountains that I mentioned in the background. They get up a lot higher than that. There are mountains that go up to 5,000 meters in Antarctica. And finally, I arrived at Concordia Station, and that is the view from my bedroom window. This is the base. I'll try and show the video. I'm not sure if it will go. Let's see. No, maybe not. In any case, the base is made up of two towers. There's a quiet tower and a noisy tower. In the quiet tower, there are all the bedrooms, and there are the offices, and there's a hospital. In the noisy tower, there's the kitchen, the workshop, and a small gym. Then all around the base, at distances of up to about 2 kilometers, are the laboratories. They're fairly easy to get to during the summer because you can use things like skidoos, and you can use transport that can work at those temperatures, because, as I will say in a moment, the temperatures in summer are quite favorable at around minus 30 or 40 degrees Celsius. During the winter, on the other hand, the temperatures get down to minus 60, minus 80 degrees Celsius, and you can't use any mechanical means. So you have to get everywhere by foot, and that includes the laboratories that are 2 kilometers or so away. This is basically a year's worth of temperature, the temperature over the years at Concordia. As you can see, the highest temperature that we ever had was in December of 2018. It was a temperature of minus 14.7. Yes, the temperature is rising slowly over the years. And the lowest temperature that there has ever been was around minus 84 degrees Celsius. In the year that I was there, we got down to around about minus 80. However, with minus 80 degrees normal, you have to add the wind chill factor. And with a wind chill factor, we arrived at minus 104 degrees Celsius. Very, very cold. And yes, I still had to go outside and work under those conditions, but it was an exciting experience. Here I also have a video showing some of the wind conditions, but I don't think it's going to play, so I will move on. So as I mentioned before, there are 100 days of darkness. So basically at Concordia, you're quite close to the South Pole, about 1,000 kilometers from the South Pole. So you get a period where there's only sun, you don't get any darkness, and a period where there's only darkness, you don't get any sun. This is just showing the map of where the sun is during the year. There's a crossover period where you slowly get longer and longer days, or shorter and shorter days in the other way around. So just to talk to you a little bit about the projects that I was working on. The first one was called the Baseline Surface Radiation Network, which has a number of observatories, all outside. So all of that work was outside every day. And it's to do accurate measurements of solar and infrared radiation fluxes. And these are to give you an idea of the energy balances of the planet, various climatic models, and also importantly to validate and calibrate satellite data. So on the left-hand side there, you can see 3 locations of the radiometers. On the right-hand side, it's showing a number of instruments that they're on the roof of one of the shelters, and one of those is part of the BSRN. It's the sky camera, which takes images of the sky. And my job was basically to look after those instruments, make sure that they weren't icing up, make sure that the data was coming in correctly, and so on. Again, I have a video here, but it's not going to work. It's showing what I had to do every week, go up this 43-meter tower and clean all the instruments as I went up, including one of the radiometers, under some pretty harsh conditions. The video shows ice crystals blowing everywhere, high winds, and so on. I'm attached to a line so that it's safe, but it was tiring. A second project I had was routine meteorological observations. So that's basically monitoring the weather conditions. I had to look after the weather stations, a celiometer. Unfortunately, this one got broken during the year, so I had to keep a good eye on that one. And launching the weather balloon, as you see on the right-hand side there, and you can do some fun things with the weather balloon. You can write messages on it and send it off into the stratosphere. Again, this is a video showing a day where it was particularly windy, blowing the weather balloon. So just to show you some of the difficult conditions that they were. One of the things I decided to do while I was there, just out of interest, was write a script to tell us where all the sondes from the weather balloon had landed. Once they'd finished their journey, basically the balloon explodes and the sondes drop down to the ground. And so this was a map I made of where all the ones during my time at Concordia had landed. And as you can see, some of them land around 200 or 300 kilometers away from Concordia. So unfortunately, all around Concordia, there are these little plastic or polystyrene radio sondes that are sitting on or under the snow, and it's difficult to collect them. A third project was the stratospheric lidar. It looks like this. It's a laser beam that you beam into the clouds. It measures the optical properties of the clouds in both the troposphere and stratosphere, because it's very powerful. It can go a long way. To study the climatology of the polar stratospheric clouds, which are only there from June to September. And they give you information about reactions that are happening on the clouds, with ozone in particular. And it also gives you the temperature profile between 5 and 60 kilometers into the air, so that you can correlate it with the weather balloon data. A final project was measuring the atmospheric aerosol. And these are more chemical experiments, basically monitoring the particles that arrive in the air at Dome C, thinking about both the particles themselves and the gaseous components, how they are transported to Concordia, how they deposit in the snow, and also any chemical transformations that they undergo. So this is one of the instruments that I was using. And now we get to White Mars. So we were a crew of 13 people, all with very, very different roles. But one of the people was a doctor, a research doctor employed by the European Space Agency. And because of those conditions that make it very similar to a mission on Mars, ESA likes to send a doctor to study the physiology and psychology of the people that stay at Concordia for the winter. So we had blood tests every month. Not only blood, but they took basically everything. There were lots of questionnaires. There were various cognition tests as well. And one in particular was the Soyuz simulator. So during the summer period, they taught us how to fly the simulator to dock the Soyuz module on the International Space Station. And then every month or every 3 months, depending on which group we were in, we had to redo a test, 3 tests of docking the Soyuz on the International Space Station to basically understand how our performance changed over time and whether astronauts would be able to retain that information under difficult conditions. We did a lot of outreach activities, so we spent a lot of time talking to schools. We did about 70 or 80 conferences with high schools and public events, which was really important to get them to know what kind of studies we were performing there. We, of course, had some free time, so outside the base, again, about 1 kilometer away from the base, there are these camels that somebody put there at the start, so you can go for a walk when it's not during the dark period and go and visit the camels and the road signs. We had parties. We cooked together. We played billiards. We played poker. last one. And we actually had a sauna as well. So we were able to warm up, even though the sauna, to get to the sauna, you had to go outside in the snow and then back outside again at the end to get back into the base. Now I'll just show you some of the photos that I took on a particular day as the season was changing from night to day. This is a photo of one of my radiometers just as the first sun was hitting it. Now, I know that this is an applied science conference, so I wanted to touch on briefly what the applied sciences could do to help study the natural sciences there in Antarctica. One of the important things would be to improve the transport and the mechanical means, because the base and all the transport that you use is based on diesel. So if we could get some method, some renewables down there, that would be fantastic. It would improve our footprint a lot. Another thing to do would be improving the clothing and so on. So as you can see in this photo, I'd just been for a walk outside and very, very quickly my mask iced up. I couldn't see through it anymore. So if we could make some kind of coating on the mask to stop it from icing up, that would be really, really useful. And we have to wear all this very heavy gear. So it would be great if we could improve the clothing that you have to wear. Also, a lot of the instruments get snow inside them or they ice up. So if you can find some way, and yes, some things are done already. So these all have heaters on them. But they're not that effective. So if we can, with the applied sciences, with material sciences, improve these conditions, that would really be a big help for studying science in Antarctica. So if you have any questions, I am here to answer them.
Well, Meganne, I have many questions, but unfortunately, I think we'll have to ask for questions, ask the audience for questions, because they're the ones who cannot maybe reach you later on. But one comment. I've seen you participating in all these, women in engineering and many other outreach activities. So next, we would like to invite you to Pakistan to, encourage our women as well to come to not only engineering, but also to go for such expeditions and take part in such interesting projects. That's good to hear. And now I'll ask some, audience to ask a question. So we have Oppo A5. It doesn't look like a name, but somebody, I think, using their phones, it's the phone code. So can you talk, please? Can you ask your question? Oppo A5S. Oppo A5S. That's the phone model. Oppo A5S. Can you ask your question, please? I've unmuted you. Can you ask your question? You're short on time, please. You need to be quick. Okay, Muhammad Arshad, I'm coming to you, so you can ask your question, right? Arshad Ali?
Can you hear me?
Yes, we can.
Okay, so it's very interesting and rare opportunity to go to Antarctica. I have not a technical question, but just I'm curious about, did you find any piece of meteorite from red Mars on your white Mars during your stay? Thank you.
Interesting question. So there are studies in Antarctica about meteorites. So there are groups that go out to particular places on the plateau and basically dig up the meteorites that they find, because it's a great place to collect them. Of course, they fall all over Antarctica, all over the world, but Antarctica is a particularly useful place to find them because there's not much else there. At Concordia itself, we don't do these studies, but there is a project on micrometeorites. So during the summer period, they go and dig up the snow, basically melt the snow and get whatever particles out of it they can. And they have identified these micrometeorites that come from the far end of the solar system, and they give a lot of information about how the solar system started.
So Meganne, life is tough anyways, so we have a lot of difficulties in our work and everything. But if I'd ask you to rate from, from 0 to 10, how difficult was these 6 months, with 13 people around in Antarctica?
How difficult? Let's say 7. But I have to say that there were ups and downs. One of the interesting things about being in those conditions is that you feel every emotion much more strongly. So if you're feeling particularly happy about an experiment, for example, you'll feel really happy. But if something goes wrong, and things do go wrong, you tend to feel quite down about it, and so you have to rely on your colleagues and just get yourself through.
That's great. So Muhammad Arshad, can you ask your question, please?
Yes, thank you so much. It was really very interesting talk. So can you please comment on what is the possibility to participate in such projects being done at Antarctica? For other peoples who are interested, for instance, in future. So how it is managed, or how it is, how it is possible?
So Antarctica is only available for scientific research, but each base is run by an individual country, or in the case of Concordia, 2 countries. So if you want to get involved, basically just look up the polar research in your country and see what they have available. In my case, I was employed on a particular project on the Baseline Surface Radiation Network through the National Research Council of Italy, but it will be different in every country.
Okay, thank you so much. But it is open for us.
Yes.
Thank you.
We have a big part of Himalayas in Pakistan, and there are huge mountains, including K2 and others,
for sure,
where we can do a lot of similar research. Actually, I think conditions are almost as tough as Antarctica. But anyways, we'd love to have you in Pakistan sometime. And I have if I go on, there will be thousands of questions. We cannot take all of them. And people have loved your talk, and they're all messaging and talking about it. And everybody's saying beautiful, great, and wonderful, and amazing work, amazing presentation. So we would like to hear more from you in future, and perhaps have you in Pakistan sometime. And
I would love to.
That's great. That's great. Thank you, Meganne, for the very nice talk. So we move ahead with the program. Unfortunately, we are a bit behind the schedule